Welcome students, myself Kaushik Pal, Assistant Professor of Department of Electronics and Communication Engineering, Guru Nanak Institute of Technology. The subject is Digital Image Processing and code is EC703A. In the previous classes we have studies about the basics of digital images and digital image processing. We will continue today's topic and we will start with light and the electromagnetic spectrum. Here we can see the visible spectrum as well as the entire electromagnetic spectrum. So what is light? Light is just a particular part of electromagnetic spectrum that can be sensed by the human eye. So the particular portion which can be perceived or which can be sensed by human eye is the visible spectrum, and that can be termed as light. The electromagnetic spectrum is split up according to the wavelength of different forms of energy. Here we can see it starts with gamma rays, then X-rays, then ultraviolet rays, then the visible spectrums, then infrared, then microwaves, TV and radio. So here the wavelength is given into nanometer. So if we carefully looks, we can easily understand the different electromagnetic spectrum and the visible spectrum among it. Reflected light. In image processing, reflected light is a very important parameter because we all know that on a particular object, if some light incident, some portion of that particular light absorbed, some portion is refracted and some portions is being reflected. So here the amount of reflected light that generally comes to our eyes, that can be perceived or sensed by our brain. So that is the reason for which we can see any object. So reflected light plays a very important role to see any object. The colors humans perceive are determined by nature of light reflected from an object. That means which light or the wavelength of the light which is coming to our eyes by reflection from any object, that determine which color we will see. For an example, if a white light is incident on any green object, it absorbs most wavelengths because we all know that white light contains all the wavelengths. That means this is the combinations of all wavelengths. So if this all wavelengths light, that means white light, is incident on any green object, it absorbs most wavelengths except the green wavelength or the green color. So the green light will come to our eyes and we can see that particular object as green. So this is the reason behind any color object. So here in this slide also some examples has been given for electromagnetic spectrum. So images can be made from any form of EM radiation. Here we can see different radiation type, wavelength, approximate scale of wavelength and different frequencies, temperature of object at which this radiation is the most intense wavelength emitted. So here we can see that the radiation type, the temperature, the frequency and the approximation scale of wavelength. So if we move forward, so we can see images from different electromagnetic radiation. The first one is radar imaging, radio waves. The second one is magnetic resonance imaging, which is also abbreviated by MRI. So MRI is very important term in biomedical imaging field. So it is also used by radio waves, then the microwave imaging, then infrared imaging, then photographs, then ultraviolet imaging telescopes, X-rays and computed tomography, positron emission tomography, that is gamma rays, and ultrasound, and this ultrasound is not EM waves. So these are the different examples of images from different EM radiation. Now there is a very important term which is known as resolution, and the question is how much is enough. That means how much resolution is good or enough for our eyes. The big question with resolution is always how much is enough. That depends on what is in the image details and what you like to do with it. That means the applications. That means the image contains what and what you want to do with that particular image, that totally decides how much resolution is enough for this. So there you can see there are two key questions, and those two key questions can also be given as an example in the next slide. So if we move forward to next slide, we can see there are two pictures. At the right side there is a picture with 4 cars and it's not so clear, and the left side we can see the same image with higher resolution version. So these two images, if we just see the left side images, then the right side images will not be very good to see. But suppose we have only the right side image, not the left side image, then it is not bad at all. You can easily count the total number of cars from that particular image. But if you want to know the number of those cars, or if you want to read the digits in the number plates, it is not possible from the right side image. So in that case you require the left side image, which will give you the clear idea about the digits written in the number plate. So this is an example by which picture on the right is okay for counting numbers of cars but not for reading the number plate. That means the purpose is very important here, that how much resolution will be enough for you to do a specific job or task. For the right side, if you want to just count the total number of cars, so in that case the right side resolution is enough, and if you want to do more clarity, then the left side images is suitable for you. So here some intensity level resolutions examples are there. Suppose if we just took closer or close-up images, then not so much details are required. So that means the extreme left side images may be of low details. Now if we have some foreground and background, that means in front is some informations and after the at the background also there are some informations, then the detail is a little bit, it should be higher, so that means it should be medium details. Now at the extreme right side we can see lots of members or lots of peoples are there. So if you want to see clearly of all of them what they are doing like that, so you require much more details. So here high details images is there. So the resolution depends on the situations and on your requirement, but you have to keep in your mind that more resolution means more information, and more information means bigger size. So the more resolution image will occupy more space in the memory location, so you have to keep in mind that also. Now we can see some charts for how many bits per image element is required. So here three images or three charts are given. One is for intensity images, that means for grayscale images, another is color images, and the last one is spatial images. So these three types of images are there. So bits per pixels is given, the range is also given, and the use is also given. Now if you see, for a binary image the range is 0 and 1, and it requires a single bit per pixels. So the range is 0 and 1, and it is generally used for very low requirement, that means for document, illustration, facts, so like this, not detail requirement is there. Now if you choose universal image, that means the physically grayscale images for photo, scan, print of low resolution, then you require 8 bits per pixels, and the range is 256, start with 0 to 255. The next one is high quality grayscale image. So that is also used for high quality photo, high quality scan document, and high quality printout. It requires 12 bits per pixels, and the range is 0 to 4095. If you require more high quality, that is known as professional, and the photo, scan and print documents will be much more higher quality of for professionals. It requires 14 bits, and the range is 0 to 16383, and the last one is the highest quality, which is generally used different type of astronomy images and biomedical images, and the range is 0 to 65535, and 16 bits are required per pixels. So all these were for grayscale intensity images. Now if we look for color images, the very simple RGB universal photo scan print required 24 bits per pixels. So it is equivalent to universal 8 bit for grayscale. So as here three components are there, one is R component, another is green component, and another is blue component. So here 3 multiplied by 8, that means 24 bits per pixels are required, and the range is 0 to 255 cube. So if we required high quality, so RGB high quality is used for high quality photo scan print, the range is 0 to 4095 cube, and it requires 36 bits per pixels. Similarly, if we required RGB professional, so it will require 42 bits per pixels, and CMYK digital pre-press printing if we require, then it is 32 bits per pixels, and the range is also given here. So the last one is spatial images. So whole numbers positions, if you increase the range, so the range and the bits per pixels also given for whole numbers, floating point numbers, and from this table, we can have some idea about how much the size of the image will be, because if a pixels require this amount of bits, so total number of pixels in an image, if we know, we can calculate the total size of the image, and how much memory it will occupy, that can also be calculated. Again, this is the elements of digital image processing. So we should have in the middle the knowledge base, and some of the bidirectional arrows are there, by which the different blocks are connected. They are image acquisition, by which we can acquire the image from problem domain. Then if we require any corrections, so filtering technique can be used, which is known as image enhancement. If the image is destroyed in some portions, that can be reconstructed using image restoration. If we want to deal a particular portions from the entire image, so we want to just bring that particular area out of the entire image, that can be done by segmentation. And if we want to deal with different features, that can be known as representation and description. And the last one is object recognition, by which we can easily separate out and identify a particular object from the entire image. Now here some definitions has been given of elements of digital image processing, which are very important, and we have to memorize all this. So what is image acquisition? Acquiring the image of interest in digital format via imaging devices such as charge cable device, that means the camera and scanner. Next is image enhancement. Image enhancement, bringing out the details that are obscured or simply highlighting certain features of interest in an image. Enhancement is a subjective process. After that, image restoration is described as the improving the quality of degraded image based on the mathematical or probabilistic models of the degradation process. Restoration is an objective process. And the last one is image segmentation here. So image segmentation is nothing but partitioning an entire image into its constituent parts or objects. Segmentation procedure consumes huge time to arrive at successful solutions to imaging problems, whereas weak or electric segmentation procedure results into total failure. Representation and description. First, if we want to know about the representation, this is converting raw pixel data from segmentation process, normally representing boundaries of region or all points in regions to suitable form for computers processing. Now what about description? Extracting attributes that results in some quantitative information of interest or are basic for differentiating one class of objects from another. Recognition is nothing but the assigning a label to an object based on its descriptors. And knowledge base, knowledge about a problem domain is coded into an image processing system in the form of a knowledge database. This knowledge may be simple details of regions of an image where the information of interest is known to be located, or may be quite complex. That is an interrelated list of all major possible defects in a materials inspection problem. Here human visual system or HVS system is given, that means the structure of human eye. From the image we can see there are lots of portions is here. The first one is the cornea. Then we can see iris, then we can see anterior chamber, then lens, then ciliary fibers, then ciliary muscles, then visual axis, then vitreous humor, then blind point, then fovea, then retina, so sclera. So these types of different portions are there in case of a human eye. So this is the two-dimensional image of an human eye. The lens focuses light from objects into the retina. Retina covered with light receptors. Now those light receptors are called cones. So there are 6 to 7 million cone cells are there, and 75 to 150 million rod cells are there. So these two cells, that means the cone cells and the rod cells, are just light receptors, and they are in the retina. Now cones concentrated around fovea, very sensitive to color. So if you want to sense any type of color, then cone cells are very important. Rod cells more spread out and sensitive to low illumination levels. That means if there is less amount of light, so less amount of light is being reflected from the object, so in that case the rod cells will be activated, and the rod cells are very much efficient for low illumination level object recognition. So here again two-dimensional human eye and the three-dimensional view of human eye is given. So from this we can easily see the different portions of a human eye in 3D view and 2D view also. So let's see the human eye a 3D view and human eye a 2D view. Okay students, so we have just seen human eye in both 2D and 3D view. Now we will move forward. Elements of visual perceptions. A human eye, nearly a sphere with an average diameter of approximately 20 millimeter, is enclosed by three membranes. One is cornea and sclera, choroid and retina. The cornea is a tough and transparent tissue covering the anterior surface of the eye. The sclera is an opaque membrane enclosing the remainder of the entire eye globe. The choroid contains blood vessels to supply the nutrients to the eye. It is heavily pigmented, stopping external lights, and is divided into ciliary body and iris. Center opening of iris, known as pupil, is about 2 to 8 millimeter in diameter. The front of iris is filled with visible pigments and its back with black pigments. The lens layers of fibrous cells is having 60% to 70% water, 6% fat, and rest portions are protein. It is highly yellowish pigmented. The retina is rich with cones and rods which are known as light receptors. The cones, 6 to 7 millions in count, are primarily located in the center of the retina, known as fovea. They are responsible for photopic, that means the bright light vision, color vision. The rods, 75 to 150 millions in count are distributed all over the retina. They are responsible for scotopic, that means dim light vision contrast. An individual is connected to an individual optical nerve and hence accounts for perception of finer details. Group of rods is connected to group of optical nerves and hence accounts for overall perception. The blind spot is in the eye is entirely deprived of the light receptors, rods and cones. So here image formation in the eye, we can see how an image is being formed in our eyes. So we can see in our eyes the flipped image is, that means the opposite image is formed in our eyes. Muscles in eye can change the shape of the lens, allowing us focus on near or far objects. An image is focused into retina, exciting the rods and cones and send signals to the brain, and the brain will again just flip the image or just to see the original one. Here also again the same example is given how the image formation is being done by human eyes. The distance between the center of the lens and the retina, called the focal length, varies from approximately 7 mm to about 14 mm. The height h of an object of height capital H perceived by an observer having a focal length capital F from a distance capital D is given by the principle of similar triangle, and the formula is given here. Now we will discuss some details about monochrome image model. So what do you mean by monochrome image? Monochrome image means black and white images. So monochrome or black and white images is a two-dimensional light intensity function denoted as fxy. So fxy is also known as the image function. The value or amplitude f of the function at any spatial coordinates xy is the intensity of the image at that particular point. So if we just consider xy as the positional information, the f will be considered as the intensity level. As light is energy, this value is non-zero and finite. That means the amount of f will lies between 0 to infinite. fxy, that means the image function has two components. That means ixy, the amount of light incident on the scene or on the object being viewed, and the second is rxy, the reflected amount of light which is being reflected from that particular object. So the formula can be given as image function fxy is nothing but the product of incident light ixy multiplied by rxy, the reflected light, where I denotes or I lies between 0 to infinite and r lies between 0 to 1. That means the amount of light which is coming from the source will rise between 0 to infinite, and the reflected light will rise between 0 to 1. That means light will come or not. For a monochrome image, the intensity of the image f at any coordinates xy is termed as gray level. So here it is denoted by L of the image at that particular point, and the minimum and maximum value of the range of the L is capital L and 0. It will lies between capital L and 0. To obtain a digital image fxy, we have to know the sampling and quantization. So to obtain a digital image, fxy must be digitized both in space and amplitude. So the digitization of spatial coordinates is known as image sampling, and the digitization of amplitude is known as gray level quantization. So image sampling and gray level quantization is very much important if we want to have an idea on digital image. The image sampling is viewed as partitioning an image plane into a grid with coordinates of center of each grid from an integer set z cross z. The gray level quantization is viewed as assigning a value from a real number set R as gray level to each grid. Hence, resulting digital image is M cross N matrix, which each matrix element represents a image element or picture element, or that is also known as the smallest entity of any digital image, pixels, and its value represents the gray level of that particular pixels. So here the examples of a digital image is given. F is the intensity value of that particular pixel and the coordinates is given in the bracket. So for the first one it is f00, and then for last one it is f m minus 1 n minus 1. Sampling and quantization continues. The number of samples or pixels m cross n required to approximate an image is known as spatial resolution of that particular image. The lower or insufficient spatial resolution results in pixel replications causing a checkerboard effect. So here we can see effect of spatial resolution checkerboard effect in the image. The first image is very much clear, but it gradually decreases the spatial resolution, so the last image is not at all clear to us, so it fails to give us a detailed idea of the image. So that means the checkerboard effects we can easily see in this image. The next is the number of discrete gray levels G allowed for a pixel in a digital image is known as gray level resolution of that particular image, and the lower or insufficient gray level resolution results in ridge like structures in smooth areas causing faults. The image is getting degraded, the quality of the image is being degraded. First one is 8 bit, next one is 4 bit, and here it is 2 bit. So we can see the quality of the image is gradually decreasing and the image quality is decreasing, and it is also seen by our eyes. And this is 1 bit image, which is known as binary image. That means there is only black and white dots. So effect of gray level resolution false contouring original 1 bit image for binary image. So here also we can see the different types of sampling and quantizations. If the quantizations levels, or we can see the different examples. So for the 8 bits, for the 2 bits, so lots of sizes are given using different values of spatial resolution. That is, if we want to see non-uniform sampling and quantizations, so the image quality that is degraded. Thank you, students. Hope you have understood all these things, and if you have any queries you can just ask.